Hello. The first main point that we're going to make today is that we will be factoring polynomials by using the greatest common factor. So, let me change here. You can see that if you start with a polynomial like this, you could factor it into these three different factors. The only one we're worrying about today is learning how to take this number, which is the greatest common factor, out of this polynomial. One way that you can think about how to do this is by using algebra tiles. If you start with a polynomial that is 3x plus 6, you could place those algebra tiles into a rectangle. There's only one way that they will fit into a nice rectangle. Then you can start sliding algebra tiles over so that the sides match. Notice that the one matches the shape, the length of this row. It also matches the sign. On this side, we'll need to put an X because we have a long row of X's here, and we want the length to match. We're also going to put some 1s. So you could see that we could multiply 3 by x plus 2. We've got 3 times x plus 2. So we could say that 3x plus 6 equals 3 times x plus 2. And you can see that we've just done the distributive property in reverse. So to check this, it's very easy. We just do 3 times x. Yes, we get 3x. 3 times positive 2, we get 6. It checks. Here's another example. If you start with x squared minus 4x, first thing to do is to take your algebra tiles and to arrange them into a nice rectangle. So we take x squared, and we need 4 negative x's. Like so. Next, on this side, we can see that the shape, for the shape to match, we need an x. For the sign to match, the one that's closest, we need it to be positive. On this side, we're going to put an x here so the shape and the sign match. And we'll put some negative 1s. Negative so the sign matches the shape that it's closest to. And 1s so that the length matches. Whoops, let's undo that. Okay, so you can see that on this side we have x. Up on top we have x minus 4. So we can say that x squared minus 4x is the same thing as x times x minus 4. And now we check by doing distributive property. If we do x times x, we get x squared. X times negative 4, we get minus 4x. It checks. Using algebra tiles is only one way that you can think about factoring by GCF. A faster way is to use an algebraic model instead of an area model. Let's start with the binomial 12a squared plus 16a. First thing we need to do is find the greatest common factor of these two monomials. Just like we did yesterday, we need to write out what the factors are. So the factors of 12 are going to be 2 squared times 3 times a squared. The factors of 16a are going to be 2 to the 4th. You could use a factor tree if you need to, times a. Now we look for the common factors. Since I'm using exponents today, I won't be using the circles, but it's still pretty easy to see. They both have 2 2's, at least. This one has more, but there's 2 2's that are in common. So I'm going to put 2 squared. They also both have at least one a. So I put a. 2 squared a is the same thing as 4a. So my greatest common factor is 4a. Okay. Now I'm going to put that 4a right in front of some parentheses. And everything that's left over is going to be what goes inside the parentheses. So what's left over, we've got a 3 left over. We've got 1a left over. I'll just put 1a because we took 1 out. On this side, we've got 2 2's. Let me show that with a pen. We'll change this. There are 2 2's that are left over now. Okay. So for the first term, I'm going to put 3a. And for the second term, I'm going to put 4. Let me delete that now. We can check by doing the distributive property. So 4a times 3a is 12a squared. That looks like what we started with. 4a times 4 is 16a, which is what we started for, and it checks. Here are the steps. First, you factor each monomial and find the GCF. That was 4a. You put 4a in front of the parentheses, and you leave all the other factors inside the parentheses. You use the distributive property to check. Let's do it again down here. This time we're going to do it a little bit more in our heads, finding the GCF. First, we look at the negative signs. There's a negative sign in one, but not the other, so we do not take a negative 1 out. What factors go into 15 and 25? 5 goes into both. Look at the variables. What do they both have? They both have a y. That's my greatest common factor. Now I'm going to do the distributive property in reverse. If I take 5y out of this term, what's left over? A negative is left over. A 3 is left over, because 15 divided by 5 is 3. And x is left over. Now we take this term. If I take 5y out of this term, what's left over? 25 divided by 5 is 5. And that's it. We check with the distributive property. If I do 5y minus 3x, I get negative 15xy. That looks good so far. 5y times 5, I end up with 25y. It checks. Good luck.